Assalamu alaikum. I introduce myself first. Hadj, Barkat, Kaarour. First, as an introduction, I present to you my work in the following topic. Effects of physical properties of GAN, IN, on LEDs 6 multi-quantum wells. Introduction. Past few years have seen tremendous progress in the epitaxial growth and chip size scallops design of JIN, multi-continuous posits. The idea here is to create multi-continuous INJIN will in order in increases the efficiency active regions and thus produce less that can operate over a wide range of infrared wavelength for ultraviolet rays. We use it we used Silva code for the LED simulation and extracted the LED power and spectrum blue or UV from the X, INX, GA1 minus X, and M of the work. The development of nitride-based LEDs presents an important scientific and industrial challenge social due to their large forbidden band semiconductor materials based on elements 3 nitrides, such as JIN, and there always are very good candidates for the production of novel optoelectronic device. However, the system has severe limitation mainly due to the evaluation of IN properties when the indium concentration increases. The effect of the stress and the bias affects the quality of the materials and thus the spontaneous emission of the LEDs in general, and when the NA and ND activation increases, the power increases. Moreover, in the context of the scarcity of natural resource, the use of indium, which is scarce and expensive substance, must be done in a rational manner. However, current system small screen mobile device requires more powerful indium-rich LEDs. The goal now is to have high-performance LEDs lights with good color rendering. The structure of LED. It consists of three regions. Regions number 1, GIN type P. As for second region, it consists of group of layers IN, GIN, and GIN alternately. Cis multi-quantum wells. The third region, GIN type N. This is with regard to the thickness of the layers and their type N or P. Simulation results. Effects of indium's concentration on emission spectrum. For X equals 0.11, wavelength equals 0.51 micrometers. For concentration of indium, X equals 0.16, wavelength equals 0.44 micrometers. Simulation results. Effects of indium concentration on emission spectrum. For concentration of indiums, x equals 0.11, wavelength equals 0.41 micrometers. For x equal 0.16, wavelength equals 0.44. For x equals 0.2, wavelength equals 0.46 micrometers. From these results, it can be seen that it is possible to change the wavelength of the light emitted by modifying the concentration X of indium in the INGN alloy. Increasing X causes a color change from purple to blue. Effects of doping on light outputs. For ND equals 2E20, luminous powers equals 46 watts. For ND equals 2E16, luminous powers equals 3.48 watts. For NA equals E17, luminous powers equals 3.46 watts. And for Na equals E21, luminous powers equals 21.7 watts. We can notice that the threshold voltage is always remains, but the power light for voltage greater than VTH increases when the increases in doping. Conclusion. This study always adds to improve our conception of some phenomenon physics of the light emitting diodes as well as the effects of some parameters, technological and geometric, on the performance and behavior of the study's diodes. Thank you for listening to me.